Good morning, everybody. Welcome back to lecture number 32. Okay? Before we start, let me walk over the syllabus again and give you important announcement. We will have Major 2 this Saturday, 6:30 p.m. It will cover up until 13.8. Last time we talked about the basic concept of diode, صح? We talked about the ideal diode model. Today we will talk about the non-ideal, the piecewise linear diode model, which is the non-ideal one, okay? Then, which is constant voltage diode model. Constant voltage diode model. Next week we'll talk about the Zener diode, rectifier circuits, wave shaping circuits. Those are the practical applications of diode. After that, we will go to I think, the easiest part of the course, which is the logic circuit concepts, and, or, etc. Representation of a numerical data in binary form, the digital signal 1 0 1 1. طالب digital. ما لحقتوا عليه. ما لحقتوا. في أحد لحق عليه؟ أحكي له. شفتوه في اليوتيوب بس ما لحقتوا عليه. طالب digital. 1 0 1 1. Okay. Combinational logic circuits. Okay? إيش هي combinational logic circuits? How can I design a counter? How can I design a sensor, etc. Measurement concepts of sensors, signal conditioning, analog to digital converters, and then we will have our final exam. They already said the date. What's the date? May 23, 24. May 24. Any question about the syllabus? Okay. So last time, what did we say? We either have diode on or diode off, right? Jihad, what did we say when the diode is off? How we represent it in the circuit? Open circuit. And we say plus minus VD. What is I diode? 0. What is V of the diode? Has to be negative. And if we assume the diode is connected or on, what do we replace it with? Closed circuit? No, that's not the technical word. Short circuit. What's the voltage drop?
Positive. 0.
0, yeah. What's the current?
Positive.
Positive. So the diode looks like that originally, okay? خط عند النيجاتيف. And we said, Rayyan, you missed the class last lecture, صح? We said in the last lecture, if we have this example, and I am intentionally repeating this example. We said if we have a battery of 2 volts, now are you familiar? This symbol is equivalent of that symbol. Which one you like? The second one? It's the same, doesn't matter. But this is the symbol of the battery. We said the battery has 2 volts, and then, what did we say? We have to do 3 steps. What's the first step? Assume. What's the second step? Analyze. What's the third step? Check. Always write it down. When we said assume, we said we look at the diode. Is the anode closer to the positive side of the circuit? In this circuit, the anode is closer to the negative, so a smart student would assume the diode is off. Is the diode anode closer to the higher voltage?
Yes.
This may not work all the time. So we said because it's closer to the positive side of the diode. Is the recording on? Yes. We said we will replace it with a short circuit. And then we connect everything else the same. Okay? The ground is here. This is 1 kilo ohm, and we said plus minus VD and I of D. You replace the diode with this component. Okay? So we're done with the assume. The second step, analyze. What do we say by analyze? What's the goal of the analyze step? Rayyan. The goal of the analyze step is to calculate VD and ID. Once you calculate them, we go to the check, which is to check with those two conditions. If they are satisfied, the assumption is correct, and that's how the circuit looks like. Any violation means quit the assumption, go to another assumption. So in this circuit, we said the voltage is 2. So what is I of D? Is Ohm's law, basic, 2 over 1K, which is 2 milliamp. Is it? Okay, what is V of D? It's a short circuit, so what's the voltage drop? 0 volts. You go to the first condition. Is ID greater than 0? Check. Is VD equal to 0? Check. So the assumption is correct, and this is the correct circuit, and the diode is on. The other circuit, note that we reverse the polarity. In the exam, we will have a reverse polarity connected to the op-amp. Let me side explanation. You remember the inverting op-amp? What if I connect a battery here of 3? What will be the voltage here?
3.
Negative 3. Okay? So when you calculate the current, it will be what? V input minus 3 over R1, let's say this. And then you continue solving the circuit. Okay? Get it? What did we call the
Virtual summing point. The
virtual summing point?
should be
No.
virtual short or something.
No, there was actually P. We gave it a summing point constraint. SPC. Summing point constraint. So a minus 3 would appear here. If it was ground, 0. Okay, what if I just connect a resistor? Same. It's 0. No current will flow. Get it? Bonasar, get it? If I connect a resistor without a battery, still 0. Because no current is allowed to enter the op-amp. Okay, go back to the diode. If I put 3 volts here, okay, well, the circuit is different, so I have to redo it. The reason I'm repeating it because it's important to understand these concepts. 2 kilo. What did we say? I diode here, plus minus. Okay. First step, assume. What did we say? We say we are smart enough to not waste time, and we know that the negative side of the battery is connected to the anode. The positive is closer to the cathode, so it's better to assume it is off. What do we replace it with? Open circuit. Plus minus VD. Now we go to step number 2, analyze. So what is IFD? This is open circuit, so no current is flowing. What is IFD, Yarayan? This is open circuit. What is IFD? What is the current that goes through an open circuit? Can current fly in the air? So what's the current?
Sometimes
0. What is V of D?
the voltage is high enough, the current can fly.
Oh yeah, that's separate. In high voltage application, you are right. If the voltage is super high, you are right. Ryan, what's the voltage drop across this circuit? This is V open circuit. What's the voltage? Not 3. Polarity. Plus, minus, plus, minus. Negative 3. Come to my office hours, okay? You have to come. So what's VD? Ryan, what's VD? Minus 3. Okay? Check the condition, ya Mishal. Is the first condition satisfied? Is VD less than 0? Check, check. So our assumption is correct.
It's okay. VD minus 3.
VD minus 3, you put voltmeter here. There is no voltage drop across the resistor because I is 0.
Okay.
So the only voltage you see is minus 3. Not VDR. VDR, you need to have a resistor and a resistor. And then you put, it's not VDR. VDR is this one. Get it? It's not the VDR. This is open circuit voltage. كأنك موصل سلك في الهواء تشبك على بطارية.
It's like KVL, but
You can do KVL. If you do KVL, it will be what? Plus VD plus 0.
plus 3.
Plus 3 equals 0, so VD equals minus 3. Okay? Now, in today's I said I'm going to solve this exercise. I said I'm going to solve this exercise. We have to solve it. Now, this is the last exercise we need to solve. Look at it. What do we have? We have a current source of 5 milliamps, صح? We have else a resistor. And we have diode number 3. We have here diode number 2. And then we have a battery, voltage source, maglub, okay? Then we have 1 kilo ohm. Look at this circuit. Let me zoom in for the camera. D4, is it connected more closer to a high voltage or small voltage? High voltage. So this is the easiest way to save time. It may not work all the time. If you violate the checks, you have to make another assumption. Especially if you have more than one diode, these things are more likely to occur. So, Sadiq, where is the Sadiq? What is the best assumption for D4? On. Salman. What is the best assumption for D3?
Off.
Why?
It's the closest to negative.
عشان نمشي لهم. طبعا this is not a scientific way, but this is مش تحس. It's more about the feeling. So we feel that the anode is closer to the negative of the battery. But someone else would say, but we have a current flowing here. That's okay. That is okay. Because if this diode is off, all of the current will go here. And let's draw the equivalent, yes.
Can I change the current source?
No, not recommended, because you do not have a parallel resistor here. So you can't do source transformation. You only do source transformation if you have current source in parallel with a resistor. Then you can replace it with VTEP.
This one.
No, there is diode here. يخرب. It has to be only a resistor to do source transformation. Plus, we don't want to mix the diode concept with the source transformation concept. It's too advanced, okay? Get it? Let's draw the equivalent circuit. And I want the help of Hatem Aziri. Where is Hatem? So, what should I replace this circuit with?
With the open circuit.
Open circuit, okay. And what should I replace this diode?
Short.
What about the polarities? Where's plus or minus, VD? diode 3?
Plus and minus.
Plus, minus, VD. What's the direction of ID?
Down.
Okay, how about this? What is the plus, right or left?
Plus is right.
Right, left, VD. What the direction of the current from right to? This is ID4, this is ID3, this is VD3, this is VD4. Let's put VD4, VD3, okay? I still have the numbers 2K here. So plus minus, I of D goes here, ID for plus minus. We are professionals. Are we done? Is there anything in this circuit that needs to be written? Everything is complete? So we go to step number 2, analyze. Let's analyze. So because this is an open circuit, we do a KCL here. So if we do KCL here, we have 5 milliamp equal to ID4 plus ID3. You agree with me? So ID4, what ID3? What is the value of ID3? 0. Why? Because it's an open circuit. So ID3 equal to 0. This implies, what is ID4? 5 milliamp. Okay. Now, the only thing remaining is I need to calculate VD3 and VD4. What is VD4? Easy, VD4. No, not the short circuit. Look, go back to this. You have to. This is the most important thing. What is VD4? Here written 0. Okay. The only thing remaining is I know ID3, I know ID4, I know VD4, but I do not know VD3. What is the best KVL loop? It is this loop. So I have to do a KVL here, okay? Who wants to be the KVL? Turkey? Where do you want to start?
From
Here?
no.
Khalas, you have to start. Okay, we say we go clockwise, right?
Yes. What is the right?
Numbers plus 10.
Plus 10.
Plus 10, 0, ignore it. Voltage rise,
What is the right was BT?
VD3. And what's the voltage drop across this resistor? 0, because there's no current. So خلى. Here,
Voltage drop.
Minus. ID4, what is ID4? 5 milli times 1 kilo equal to 0. So VD3 equals minus 10 plus 5, which is minus 5 volts. Is it less than 0?
Yes.
So go check the condition. For D3, is ID3 0?
Yes.
Correct. Is VD3 negative?
Yes.
Correct. So the assumption is correct for diode number 3. How about diode number 4? Is ID positive?
Yes.
Correct. Is VD4 0?
Yes.
Correct. So all the assumptions are correct. And diode 3 is off. Diode 4 is on. Hopefully you know now how to solve these circuits. With 2 diodes or 1 diode?
Question.
Yes.
If I get one assumption is correct and the other is wrong,
Everything is wrong.
everything.
Then you have to make another assumption. Maybe you can assume diode 4 is on, diode 3 is on. Or you can assume diode 4 is off, diode 3 is off. Or you can assume diode 3 is on, diode. You have to try 4 combinations. But the hint I gave you, where you look at D3 is closer to the negative, it's going to save you some time. توفر عليك وقت. Get it? Okay. Then we talk about 9.5. There is a problem with this diode model. The problem is, it's not realistic. Why it's not realistic? Because if you go to the lab and you bring a diode in the lab, and you bring a voltmeter and you measure VD of the diode, you will find it is equal to 0.7 or 0.6, even if it's not connected to the battery. This is one feature about the diode, is it has a potential voltage. From where this potential voltage comes? Do you remember at the beginning I told you about the structure of the diode? Is it has a gap in the middle?
Yes.
You remember I told you it has an electric field here, because the positive electrons and the negative electrons are sitting. If you do not apply any voltage, they will create an electric field equal to the 0.7 volt or 0.6 or 0.8, around this number. ثابت يعني على حسب الشركة المصنعة. Because of that, you cannot assume it's a short circuit. We need to use the constant voltage diode model. And instead of this model, which is the ideal, we have to use today, in today's lecture, we can use a more accurate model of the 0.7 model. Do you want to call it the 0.7 model? It can be 0.6, it can be 0.8, depending on the manufacturer. But today, we will replace this with a battery of 0.7 volts. In other words, if you want to solve the circuits, instead of a short circuit, it has to be a 0.7 volt. And VD, it's not 0 anymore, it's 0.7 volts. That's what we call a constant voltage diode model in the syllabus. Constant voltage diode model. Why? Because if you go to the lab and measure the voltage across the diode without connecting it to any circuit, just the diode, and you put the plus and the negative and the khat, you will measure 0.7 or 0.6. And this is one of the tests where you know if the diode is not working, is you go in the lab, if you don't find any voltage, and the diode محروق. If the diode doesn't give you 0.7, and the diode خربان. The chemical structure is damaged, so no 0.7 or 0.6 or 0.8 voltage is applied. So going back to section 9.5, the only part that is required is constant voltage. A more advanced model would include resistor on top of the battery, but this is for EE. For you, it's enough to know about that is you replace it with the 0.7, which is what we call it VF. So a simple piecewise linear diode equivalent circuit, it is an open circuit in the reverse bias region, diode is off, or a constant voltage drop of 0.7 or 0.6 or 0.8, depending on the manufacturer, in the forward direction. So do you remember the curve where we had like that? The curve now is shifted to VF, where VF is 0.7 volts. So VF is the forward voltage, it is the voltage required to turn on the diode. This implies that in order for you to ignite the diode, to let the current flows, you have to apply a voltage more than 0.7 to ignite the diode. Which will happen even if you connect it with 10 volts. 10 is way larger than 0.7, so it should turn it on. So the same technique we used about guessing, we can use it for the diode, okay? Remember in the ideal diode model, we had short circuit. Here we have, in the CVDM, we have a battery. How do we solve these circuits? Well, to solve this circuit is Let's look at this example. Do you remember this example from the last lecture on the top? What did we say? We have 5 volt. So 5 volt is closer to the anode, so it will be on. So what is I of the diode? 5 over 2.5, which is 2 milliamp. If you connect with a short circuit. If you replace it with a battery of 0.7, the only difference is we will have a battery of 5 volts. Then we will have a 2.5 kilo ohm. Then we have another battery of 0.7. Do you remember the node voltage equation, ya Fawaz? You're not happy, you can leave. Do you remember how to calculate I of E?
Yes.
What is the equation? Yeah, 5 minus 0.7 over 2.5. What is the answer? 1.72 milliamp. So the current here is 1.72 milliamp in the constant voltage diode model, which was 2 milliamp in the ideal diode model, or it has a VD is 0 in the ideal, but VD is 0.7 in the CVDM. So how many models we have for the diode so far? 2. Depending on the question, he will tell you, use ideal diode model, use CVDM. Technically, the only difference is you replace the short circuit with a battery. Get it? Yes.
So we only have one equation to check the ID.
It's the same equation for the ideal, you just change it with 0.7. No. We repeat the same thing. You have to check the 2 conditions. If the diode is off, it doesn't matter. It should be negative voltage. As a matter of fact, if the diode is off, it actually should be minus 0.7, but keep it negative, okay? ما راح تفرق الأرقام واجد. Okay? So let's use a big example, scary example. This example, okay? So what do you have? Always look at the elements you have. We have a 4 volt battery. We have a 200 ohm, another 200 ohm, a 300 ohm, 100 ohm, and we have a diode. A smart student, what would he assume?
No, close. Open. Short circuit.
What did we assume? Assume is either diode is on or off.
Short circuit.
لازم تقرر من البداية. Look at it. The anode, it's closer to the 4 volts, صح? So a smart student would say, I will assume it is on. But I'm not going to do that. I'm going to assume it's off, solve it, and then assume it's on and solve it. Okay? So let's pretend that we are not smart, and we said let the diode be off. What will be the equivalent circuit? This one. So how many voltages you need to calculate? V1 and V2 to get VD. What is VD? V1 minus V2. So we have here a 300 ohm, 200 ohm, 200 ohm, plus minus 4. We said this is an open circuit. This is plus minus VD. ID is 0. We only have one diode. This is 100 ohm. It is labeled here. This is V2. So what is V of diode? It's V1 minus V2. It's like VA minus VB. Same. So if I know V1 and I know V2, I can calculate VD. And now I can see if VD is positive or negative, We can apply the check conditions. Okay? So what is V1? V1 we can do a KVL here, but we can use VDR. Why? Because I have one cable here, one cable here. The whole current here will swim there because there is no current here. And I can use VDR. So what is V1 using VDR? Is 200 over 200 plus 200 times 4, which is 2 volts, correct? Now, for the same logic, what is V2? VDR. 100 over 300 times, 100 over 100 plus 300 times 4. So what is V2? 100 over 400 times 4, which is 1 volts. So what is VD? V1, 1 minus 2. No, 2 minus 1. 2 minus 1 is 1 volts. So we have this, and we have ID is 0. Is ID equal to 0? Correct. Is VD negative? Not correct. So the assumption is wrong. What is the correct assumption? Is the smart student, now he's solving this, probably he's about to finish because he made the correct assumption. What I want you to learn is have this mental ability to check if the diode is on or off to save time in the exam. 3 minutes saved, okay? This is about the finding. Remember, the hardest chapter in this course is the diode. Because we'll have Zener diode, we'll have rectifiers. So please understand it. Do not memorize. The only thing to memorize is these things. Okay, if we replace it with the model, but here he is telling us to replace it, assuming that the diode operates at a 0.7 volt. So you need to use the CVDM. Constant voltage diode model. Ya Abu Saud. Door is open. Okay? So let's replace it with a short circuit. No, wrong. Replace it with what? Another battery. What's the voltage drop across this battery? Where is the plus and minus? Minus, plus, VD equal 0.7. 90 enters here. Okay, in order for me to verify the conditions, I need to calculate VD, which is already given, 0.7, and ID. What does this circuit remind you? A major one. Which is not going to come, inshallah, متفائل ما يجيك major 2. Super node. So this is a super node, صح? Super node is when you have two nodes that has a battery on it. So if you want to know the node, you assume the whole thing is a node, and you calculate all the currents here, 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 and here. Then you calculate V1 and V2, and then you can calculate ID. You can do it by mesh. I don't like mesh. Okay? You want to do it by mesh? Don't have time. But let's do it by mesh. Okay, I'm going to use, it's solved by both methods. I'm going to use your method of mesh, okay? So you don't want to do super, no. Let's do it with the mesh. Okay, we are professionals, right? How many currents we have? IA, IB, and IC. How to make the signs? Plus, minus. What's the current here? Is IA minus IC. How about the 200 ohm here? Plus, minus, it's what? IA minus IB. How about this resistor? It's IB. How about this resistor? Do we have passive sign configuration? Do we have current enters at the negative terminal? No. What is ID? Is IB minus IC. ID is IB minus IC. So let's do the 3 KVLs. نمشمشها. Okay, who wants to do the first loop?
Start from ground. Plus 4. Then plus I.
Not plus voltage drop.
Sorry. Minus 200. IA minus IC. Then minus 200. IA minus IB.
Who wants to do loop number 2? Turkey? This one. No, this one. Where do you want to start? Here?
Okay. 0.7.
Wrong.
Minus 0. Minus 7.
Minus 0. Voltage drop. Here?
Minus 100 IB.
Here? Voltage rise or voltage drop?
Plus 200 IA minus 8.
Who wants to do the third loop?
Left corner.
Okay.
Minus IC.
What's the voltage? 300.
Minus
So minus
300
300
IC.
IC.
Plus 0.7. Plus 200 IA minus IC.
Standard form. Can I erase this? Who wants to do the standard form? May come in the major 2 by. Yes. Is there a mistake?
I think we have sign configuration because it's going
What is the sign configuration?
minus 200. This voltage.
This one or this one?
No. In
Harry?
IC.
Harry?
Here.
No, it is. This current is IA minus IC. It enters from the positive.
بس احنا أخذنا اللوب زي كده.
No, the current enters from the positive still. الكرنت هذا هو IA minus IC. اسمه IA minus IC. Where it enters? From the positive terminal. So we have a voltage rise. We're experiencing a voltage rise of this. عشان كده الطريقة أنا قلت لكم يا voltage rise والدروب تقلل الباسيف ساين بس لو كان الكرنت IA minus IC بيدخل من هنا حيصير سالب. Trust me. You're correct, صح? Standard form, guys. What is the standard form? We are professionals now. We can do it. IA, IB, IC. So what are the coefficients of IA here? Minus 200, minus 200, minus 400. IB is 0, صح?
لا IB 200.
IB is 200. And IC is what? 200. 200, 200. What's the constant? Plus 4. It will be minus 4. What's the second one? IA is 200. And what is IB?
minus 300.
It is minus 200 minus 100 is minus 300. And there is no IC, right?
Yes.
What's the constant? Do we do have? Oh, we have a
0.7.
0 plus 0.7. What is the third equation?
200.
200. What is IB?
0.
What is IC?
Minus
100.
Minus?
500.
Minus 500.
Minus 1.
What is the constant?
Minus 0.7.
Minus 0.7. Solvers, please. Calculator, solve. All of you. You know how to solve it now. خلاص. So this is what I got. IA equals 0.0204 amps. IB 0.01129 amp. And IC, it's very small, I think it's 0.00957 amp.
Yes. Same.
So what is I of the diode? I diode is IB minus IC. So it's 0.01129 minus 0.00957, which is 1.72 milliamp. Is it larger than 0? Correct. And is VD equal 0.7?
Yes.
Correct. So both conditions are satisfied, and the diode is on. And the smart student, from the beginning, he said, because the anode is closer to the 4 volt, the diode is on, and that's how to solve this example. Now, we don't have time to solve it maybe before the mini major, which we will have it Thursday. So on the Thursday, we will have the mini major. I don't know how much time. I haven't written the question. It could be 2 questions. It could be 5. It could be 6.
Written or MCQ?
MCQ, I think.
What about the major? MCQ?
MCQ. 20 questions MCQ. So the mini major, which is quiz 6, also MCQ. You get it all wrong, you get 0.
mini major. I thought it was
It is a quiz, same weight.
بس
تبغى تحذفها you can eliminate it. If it's your lowest, it will be eliminated, etc. Okay? I want you to study hard for the mini major, especially the homework. Okay? Study the homework, do your best. It will be from probably the slides and the homework, and maybe
Chapter 13? Chapter 13?
all. No, I'll make it 13 and 5 and 9, but 13 is easy. So maybe I'll give you 1 or 2 easy. Maybe I'll give you 1 quiz. It's mini major, يعني. كل واحد.
9, Doctor.
9?
No, not 9. 3, 13, and 5. It's a mini major. Okay? Any question?
Listen.